A sixth-generation fighter is a proposed class of jet fighter aircraft that surpasses the capabilities of the current fifth-generation fighters in service and development. The United States, Russia, and China have each announced plans to develop their own national sixth-generation aircraft programs. Additionally, countries like Japan, Italy, and the United Kingdom are participating in multinational collaborations, such as the Global Combat Air Program, while France, Germany, and Spain are working together on the FCAS project to share development and procurement costs. The first sixth-generation fighters are anticipated to enter service in the 2030s. In 2010, the Japanese government introduced a concept for a sixth-generation jet fighter, the I-3 fighter, where I-3 stands for Informed, Intelligent, and Instantaneous. In July 2014, Jane's Information Group reported that the UK's House of Commons Defence Select Committee had released a report on the post-2030 Combat Aviation Force structure. The report suggested the UK might commit to a next-generation fighter program to potentially replace the Eurofighter Typhoon after 2030. However, the Typhoon's service life has since been extended to around 2040. On 22nd March 2016, Japan carried out the first flight of the Mitsubishi X-2 Shinshin testbed aircraft for this project. In July 2018, British Secretary of State for Defence Gavin Williamson unveiled the UK's combat air strategy and announced the development of a sixth-generation fighter concept named Tempest for the Royal Air Force at the Farnborough Air Show. In 2019, Sweden and Italy joined the Tempest project, followed by India and Japan being invited to participate. On April 1, 2020, Japan announced its FX program. By 2022, Japan merged its FX project with the Tempest development, creating the three-nation Global Combat Air Program after close collaboration and a retreat from its industrial partnership with Lockheed Martin. Japan also chose to focus on separate drone development. 2 weeks after the UK, Italy, and Japan's agreement, Sweden signed a bilateral defense trade agreement with Japan, allowing them to remain an observer in the program with the option to join as a development partner in the future. France, Germany, and Spain have united within the framework of the Future Combat Air System (FCAS) program to jointly develop a sixth-generation fighter aircraft known as the Next Generation Fighter (NGF). The FCAS initiative aims to create a cutting-edge air combat system that will integrate advanced fighter jets, unmanned aerial vehicles (UAVs), and sophisticated network-centric technologies to ensure air superiority in the future. The Future Combat Air System, known in French as Système de Combat Aérien du Futur, in German as Zukünftiges Luftkampfsystem, and in Spanish as Futuro Sistema Aéreo de Combate, is a European defense initiative being developed by Dassault Aviation, Airbus, and Indra Sistemas. The FCAS will integrate a next-generation weapon system, NGWS, alongside other air assets for future operational environments. The NGWS will feature remote carrier vehicles, or swarming drones, and a new generation fighter, NGF, a planned sixth-generation jet fighter. The NGF is expected to eventually replace France's Rafale and Germany and Spain's Eurofighter Typhoons. A test flight of a demonstrator is projected for around 2027, with the system expected to enter service by 2040. The NGF is envisioned as the centerpiece of this future system, featuring advanced stealth capabilities, enhanced sensors, and AI-driven combat systems, which will allow it to operate alongside unmanned aircraft and drones in a highly interconnected environment. The FCAS program is designed not only to replace the aging fleet of European fighter jets, like the Dassault Rafale and Eurofighter Typhoon, but to also ensure that European nations retain technological and strategic autonomy in the face of evolving global defense challenges. The three countries, France, Germany, and Spain, are working together on the development of this next-generation fighter, with Dassault Aviation leading the French efforts, Airbus Defence and Space playing a key role for Germany and Spain, and other defense contractors contributing to various aspects of the project. The NGF is expected to incorporate cutting-edge technologies such as hypersonic weapons, advanced electronic warfare systems, and highly integrated avionics to meet the demands of future air combat. The first flight of the NGF is anticipated in the 2030s, with the aircraft expected to enter service around the same time. The FCAS program reflects a broader European effort to strengthen defense cooperation within the EU, pooling resources and expertise to develop a fighter system that will maintain Europe's competitive edge in the global defense landscape. On 26 August 2013, Russia revealed plans to proceed with the development of a sixth-generation jet fighter, with speculations that the aircraft could potentially be pilotless. Despite this ambitious leap forward, Russian officials emphasized that the development of existing fifth-generation fighter projects, such as the Sukhoi Su-57, would continue and not be overshadowed by the new sixth-generation program. One of the key components of Russia's future air combat strategy is the Mikoyan PAKDP, a next-generation interceptor aircraft aimed at replacing the aging Mikoyan MiG-31, which has been in service since the 1980s. The PAKDP is being developed by Mikoyan and is expected to enter service with the Russian Aerospace Forces in the mid-2030s. While often referred to as the MiG-41 due to its project code Izdeliye 41, Product 41, the aircraft has not yet been given an official designation, as Russian military aircraft typically receive their formal names only when they are nearing production or service. The PAKDP is envisioned as a stealthy, heavily armed interceptor and heavy fighter with advanced capabilities designed to counter new threats in the airspace of the future. These may include capabilities such as hypersonic weaponry, advanced stealth features, and the ability to operate in highly contested environments. Russian defense analyst Vasily Kashin has suggested that the PAKDP could be categorized as either a 5++ or a sixth-generation fighter, reflecting its advanced technologies and unique role within the Russian military. In January 2021, Rostec Corporation, which owns Mikoyan, confirmed that the PAKDP had entered its development phase. Rostec's announcement emphasized the importance of the new interceptor, stating, "Development of the next generation of interceptor fighters has already begun." This suggests that much like the Su-57's role as Russia's first fifth-generation fighter, the PAKDP will play a critical role in advancing Russia's air defense capabilities as part of its broader vision for next-generation aerial warfare, making it a cornerstone of Russia's future air combat system. The United States is preparing to introduce its first sixth-generation fighters around the 2030s. Both the United States Air Force and the United States Navy are actively pursuing advanced programs to develop these next-generation aircraft, building on their current fleets and maintaining air superiority well into the future. The USAF is leading the development of its sixth-generation air superiority fighter through the Next Generation Air Dominance program. This program is designed to succeed the Lockheed Martin F-22 Raptor, which has been a cornerstone of U.S. air dominance since its induction in 2005. The NGAD program aims to create a highly advanced fighter that can operate in complex contested environments, leveraging cutting-edge technologies like artificial intelligence, autonomy, and advanced networked systems. The goal is to ensure continued U.S. supremacy in the skies through an integrated system of manned and unmanned platforms, sensors, and weapon systems. The NGAD will likely focus on long-range, stealthy, and agile capabilities to counter increasingly sophisticated threats from near-peer adversaries. The U.S. Navy is pursuing a similar effort known as the FASX program, which is intended to complement the smaller Lockheed Martin F-35C Lightning II. while also replacing older aircraft, such as the Boeing FA-18 Super Hornet. The FA-20 will be developed to meet the specific operational needs of the Navy, particularly for carrier-based operations. It will likely emphasize stealth, supersonic speeds, and advanced onboard systems, including radar and electronic warfare capabilities, to maintain air superiority in hostile environments, especially in the face of advanced enemy surface-to-air missile systems. The FA-20 is also expected to incorporate unmanned systems and advanced AI to enhance mission flexibility and reduce the risks to human pilots. The U.S. Navy launched its FAXX program in 2008, while the USAF sought initial responses for a next-generation tactical aircraft, Next Gen TACAIR, in 2010, which later became known as the FX program. These efforts were focused on the development of cutting-edge fighter designs that could meet the demands of future combat scenarios, incorporating capabilities that existing platforms could not achieve. In April 2013, the U.S. Defense Advanced Research Projects Agency initiated a study to combine the USAF and USN concepts into a unified vision for next-generation fighter technologies. This initiative was part of DARPA's broader Air Dominance Initiative, which aimed to develop prototype X-planes for both branches of the military. However, the RAND Corporation's 2013 analysis recommended that the U.S. military services avoid joint programs for sixth-generation fighter development. The study found that differing requirements for complex programs often led to costly design compromises, making single-service programs more cost-effective and efficient. By 2014, a broader approach to offensive technologies was proposed. Instead of focusing solely on a single sixth-generation fighter, the USAF envisioned a future where aircraft operated alongside ground-based systems and non-kinetic anti-aircraft solutions, offering greater weapon loads and a more diversified set of mission capabilities. This vision was solidified in 2016 with the introduction of the Air Superiority 2030 Plan, which emphasized the pursuit of a network of integrated systems disaggregated across multiple platforms, rather than focusing exclusively on a single fighter design. The Air Force and Navy had already merged their requirements the previous year, with a joint emphasis on AI systems and a common airframe design to unify their future fighter development. Boeing, Lockheed Martin, and Northrop Grumman have all launched sixth-generation aircraft development projects, positioning themselves to play a key role in the U.S. military's future air combat capabilities. Each company is exploring different aspects of next-generation fighter technologies, ranging from advanced stealth to AI-driven autonomy and enhanced sensor fusion. On September 14, 2020, the U.S. Air Force announced a significant milestone for the NGAD program, revealing that a prototype component of the aircraft had flown for the first time. However, the details of the prototype remain classified, as the full scope of the NGAD program is still under wraps. This marks a critical step in the development of a fighter that is expected to revolutionize U.S. air power in the coming decades. In summary, the U.S. is pushing forward with multiple parallel efforts to develop its sixth-generation fighters, focusing on air superiority, advanced networking, and AI systems. The USAF's NGAD and the USN's F/A/XX programs will redefine the landscape of aerial combat, ensuring that the United States maintains its edge in the evolving global defense environment. The development of sixth-generation fighters for both the United States Air Force and the United States Navy is guided by distinct visions, though there are fundamental areas of agreement between the two branches. Both services are incorporating cutting-edge technologies such as artificial intelligence to assist pilots in decision-making, enhancing sensor fusion, and improving communication systems. Additionally, positioning, navigation, and timing (PNT) technologies will be integrated, enabling seamless data sharing between aircraft across both services. The U.S. Air Force prioritizes stealth technology for its 6th-generation fighters, with a particular focus on enhancing survivability. In contrast, the U.S. Navy, while valuing survivability, emphasizes speed and payload capacity, arguing that these factors should not be compromised in the pursuit of stealth. The USAF's approach contrasts with the development of earlier fighters like the F-22 and F-35, which suffered from delays and rising costs due to the introduction of new technologies. To avoid similar issues, the U.S. Air Force plans to adopt a more methodical, risk-reducing approach, incorporating extensive prototyping, technology demonstrations, and systems engineering before actual aircraft production begins. The U.S. Air Force envisions that 6th-generation fighters will surpass the limitations of current strike aircraft. These future aircraft will require a comprehensive theater-wide integration of systems, beginning with advanced airborne sensors and extending to real-time data integration with ground-based detection and support aircraft. The integration of AI for data processing will significantly enhance situational awareness and reduce pilot workload, while also enabling longer operational ranges and seamless cooperation with ground-to-air defense systems. Additionally, the ability to deploy aircraft in various configurations, manned, optionally manned, or unmanned, will add flexibility to operational strategies. In March 2015, the U.S. Navy and Air Force collaborated to explore a joint analysis of alternatives for next-generation fighters, which was expected to be released in 2016. This joint effort aimed to develop a shared understanding of the requirements for each service while allowing for tailored solutions. The Navy's focus is on replacing the capabilities of the F-18 Super Hornet and EA-18G Growler with an emphasis on enhancing speed and range. The Navy is also considering how the F-35C, as a forward sensor node for carrier air wings, can inform the development of the 6th-generation FA-20X. In April 2015, the Center for Strategic and Budgetary Assessments released a report advocating for a larger, bomber-like airframe for the next-generation U.S. Air Force fighter. The report analyzed over 1,450 air-to-air engagements since 1965 and concluded that long-range weapons and advanced sensors had diminished the relevance of traditional dogfighting. As advanced air defense systems and high-speed weapons become more prevalent, smaller, highly maneuverable fighters may be more easily targeted. The CSBA suggested that future fighters should be larger, equipped with enhanced sensors, long-range weapons, and advanced networked situational awareness. These larger aircraft would have greater operational range, higher detection capabilities, and carry more powerful and longer-range missiles, such as long-range engagement weapons. This concept aligns with the development of long-range strike bombers, which could provide strategic flexibility and reach. In November 2016, the U.S. Air Force's Scientific Advisory Board began studies for a penetrating counter-air PCA platform. The PCA is envisioned as a long-range, supersonic fighter with advanced stealth, capable of operating in contested environments, including deep into adversary airspace. The aircraft would be designed to counter advanced air defense systems, such as those employed by Russia and China, and operate effectively in regions where air bases may be unavailable or vulnerable. The PCA would include stealth features to evade low and high-frequency radar systems like the S-400, and its design could feature no vertical stabilizers to reduce radar cross-section. A larger payload capacity would allow the PCA to carry more ordnance than current air superiority fighters, while an adaptive cycle engine could improve performance, providing both supersonic speed and efficient cruising capabilities. The PCA concept is positioned to complement strategic bombers and provide a robust air dominance capability. 6th-generation fighters are expected to utilize engines with adaptive cycle technology, allowing for more efficient operation across various speeds and altitudes. These engines would offer optimum performance at both high speeds, turbojet mode, and lower speeds, turbofan mode, significantly improving range, acceleration, and fuel efficiency. The Air Force's Adaptive Engine Transition Program, AETP, and the Navy's Variable Cycle, Advanced Technology, VCAT program are both focused on developing these next-generation engines. The goal is for a production-ready engine by 2028 for the Navy and by 2032 for the Air Force. Key players in engine development include General Electric and Pratt & Whitney, both of which have been involved in risk reduction efforts since 2012. The USAF is also exploring the integration of laser weapons into its sixth-generation fighters. These could serve both as low-power systems for illumination and as high-powered weapons capable of destroying targets. In November 2013, the Air Force Research Laboratory issued a request for information, ERFI, to gather insights on the potential applications of laser weapons in military aircraft. This technology could offer a revolutionary shift in air combat by providing a new cost-effective means of engaging targets at various ranges. Following the success of its fifth-generation J-20 fighter, China has turned its focus to developing a sixth-generation aircraft. Dr. Wang Haifeng, the chief designer at Chengdu Aerospace Corporation, confirmed that China began its pre-research efforts for the sixth-generation fighter in January 2019. Experts predict that the program will culminate in the deployment of a sixth-generation aircraft by 2035. In February 2023, Aviation Industry Corporation of China unveiled a concept for its next-generation fighter on social media. This concept featured a diamond-shaped wing configuration and a tailless design, which echoed earlier designs presented by AVIC. Notably, in 2018, Chengdu Aerospace Corporation submitted 8 different proposals for the sixth-generation fighter. Of these, 4 designs underwent testing in low-altitude wind tunnels to assess their aerodynamic properties and feasibility. In November 2024, AVIC released footage of a mock-up of its proposed Baidi B-type, also known as the White Emperor fighter. This aircraft is being touted as an integrated space air fighter, capable of operations in both the atmosphere and space. However, critics have expressed skepticism about the claims regarding its space operations capabilities, citing the lack of clear evidence to support such ambitious features. While official details remain limited, the Baidi B-type and other proposed sixth-generation fighters from China are expected to incorporate advanced technologies that include AI integration, enhanced artificial intelligence for decision-making and autonomous operation, hypersonic speed, potential for hypersonic flight capabilities, advanced weapon systems, likely to include new types of weapons including directed energy or hypersonic missiles, manned and unmanned operations, the ability to operate both with a pilot and autonomously. As China progresses in developing its sixth-generation aircraft, it is clear that the technological and strategic ambitions are substantial. However, many aspects of the program, particularly the space capabilities, remain speculative and will require further evidence to substantiate the claims. In an interview on the 8th of October 2020, marking the 88th anniversary of the Indian Air Force, Air Chief Marshal Rakesh Bhadauria discussed India's plans for sixth-generation technologies in combat aviation. He emphasized that the IAF has a clear roadmap for integrating advanced technologies into their future systems. These include directed energy weapons, advanced lasers or microwaves to disable enemy targets, smart wingman concept, autonomous or semi-autonomous aircraft working alongside manned fighters. Optionally, manned combat platforms, aircraft that can be piloted or operated autonomously. Swarm drones, the use of multiple drones for tactical advantage, potentially overwhelming enemy defenses. Hypersonic weapons, missiles that travel faster than 5 times the speed of sound, offering superior strike capabilities. integration with the AMCA project. India is currently focusing on developing the Advanced Medium Combat Aircraft, a fifth-generation fighter that will incorporate certain sixth-generation technologies. While the AMCA is primarily a fifth-generation platform, it is expected to feature some of the advanced capabilities typical of sixth-generation fighters, such as stealth, supercruise, and potentially some form of AI-assisted operations. The AMCA's development aims to strengthen India's air defense capabilities while preparing for future combat scenarios that require cutting-edge technologies. In a 22 October 2021 interview, India's new Air Chief Marshal, Vivek Ram Chaudhary, reaffirmed that the IAF is committed to exploring and incorporating sixth-generation technologies into its future combat systems. This indicates that India is not only focused on the present, but also preparing for the future of aerial warfare with a long-term vision. India's continued development of both fifth- and sixth-generation aircraft suggests a progressive approach to air combat technology. With plans for advanced weapon systems, autonomous platforms, and hypersonic capabilities, India aims to build a future-ready air force that can keep pace with global advancements in military aviation. On the 6th of May 2024, during a press event at the Embraer factory in São José dos Campos, São Paulo, Luiz Hernandes, the Director of Industrial Cooperation of Saab in Brazil, revealed that Brazil intends to develop its own sixth-generation fighter. This ambitious project will build on the technologies from the Saab JAS-39 Gripen, which is currently in production in Brazil. The partnership will involve collaboration between Embraer, Brazil's leading aerospace company, and the Department of Aerospace Science and Technology, a key institution within Brazil's defense sector. The collaboration between Embraer and DCTA represents a significant leap in Brazil's defense and aerospace capabilities. The plan to develop a sixth-generation fighter marks a strategic move to not only advance Brazil's air power, but also to position the country as a key player in the global defense industry. The project will leverage the existing technology and experience gained from producing the Gripen fighter, which already incorporates advanced features like stealth, multi-role capabilities, and advanced avionics. Walter Pinto Jr., the Vice President of Embraer's Defense Division, confirmed the early stages of the project, highlighting that the company envisions the development of a next-generation fighter as part of its growth strategy. He described this venture as an opportunity for Embraer to take higher flights in the field of fighter aviation, reflecting the company's ambition to expand its role in military aviation. However, Pinto Jr. noted that for the project to become viable, a comprehensive business plan is necessary to ensure long-term success and sustainability. While the project is still in its conceptual stages, the collaboration between Embraer and Saab, along with the involvement of Brazil's aerospace and defense institutions, underscores the country's commitment to advancing its air defense technology. The development of a sixth-generation fighter will likely bring cutting-edge capabilities to Brazil's military forces, strengthening its position in the global aerospace market and ensuring that the Brazilian Air Force remains competitive in the face of evolving aerial threats. The evolution of jet fighter technology has been marked by continuous innovation, driven by both the need for enhanced performance and the changing dynamics of aerial combat. From the early days of the Me-262, which marked the advent of operational jet fighters, to the highly versatile third-generation aircraft like the Hawker Siddeley Harrier, each new generation has built upon the lessons learned from the previous one. The introduction of advanced technologies such as afterburning engines, radar-guided missiles, and multi-role capabilities significantly transformed the capabilities of fighter aircraft, enabling them to perform a broader range of missions with greater effectiveness. As we move towards sixth-generation fighters, the trend of integrating cutting-edge technologies such as artificial intelligence, hypersonic weapons, and VTOL capabilities continues to shape the future of aviation warfare. Ultimately, The development of these aircraft reflects the ongoing pursuit of superior performance, adaptability, and tactical advantage in the skies.